My name is Bradley Justison, and I am a member of the University of Florida's Student ACI chapter. We are excited to participate in this iteration of the ACI Concrete Solutions Competition. During the past two Concrete Solutions competitions, our team explored a new student competition envisioned to increase student involvement in ACI, as well as the potential of concrete buoys to contribute to coral reef growth. With both projects, our team spent many hours compiling and proposing novel concrete ideas on investigating our chosen idea and presenting on the impacts of our research. For this competition, we aim to explore and expand upon sustainable practices that can revolutionize the concrete industry from both a research and an industry perspective. Our UF-ACI team aim to pave the way towards the future by incorporating recycled concrete aggregate, also known as RCA. RCA is composed of recycled material, including crushed concrete and asphalt debris. Because RCA incorporates recycled material, it is a more sustainable option in comparison to mining for other aggregate sources. Currently, RCA is primarily in use as a gravel replacement for roadway and driveway construction, as well as geotechnical foundations. RCA is also used for controlling erosion, as it is used to add stability in retaining walls. Limitations to the use of RCA stem directly from composite concrete structure, including a decrease in compressive strength in comparison to the source concrete compressive strength, as well as an increase in water absorption.
I'm Wes Brackman, and I will be discussing the recycled concrete aggregate production and testing. When producing RCA, the first step is to select the source material. This is, as suggested by the name, existing concrete that is slated for demolition and/or removal. After selecting the source material, the concrete is mechanically crushed and is then pulverized using a pulverizing machine in order to obtain small sizes of aggregate. After the RCA is pulverized, it is then put through a sieve shaker where aggregate sizes can be selected based on their size. Different sizes of aggregate produced from the sieve shaker can be used in mixed design calculations. Moving on to the standardized testing methods we use for evaluating recycled concrete aggregate. The tests are performed in order to determine the necessary material properties of the RCA, which are performed following ASTM standard test methods. The compressive strength and tensile strength of the source concrete are obtained by following the testing procedures outlined in ASTM C39 and ASTM C1583 respectively. These results will be used as a guideline to predict the strength of the RCA based on research, which produces an estimated loss of strength during the RCA production process. Testing data for absorption, oven dry specific gravity, and saturated surface dry specific gravity of the aggregate can be obtained by following the test method prescribed in ASTM C128. The evaporable moisture content of the aggregate was determined by following the procedure outlined in ASTM C566. Other relevant tests on the aggregate can also be performed depending on necessity and use.
Hello, my name is Madeline Murphy, and I'm the president of the UF-ACI chapter. Here at UF, we do a lot of concrete research, and the concrete research has inspired our student design competition teams to innovate with concrete as well. As a mixed design for last year's UF Concrete Canoe team, we chose to innovate within our aggregate source by introducing RCA into our mixed design, which served as the inspiration as well as a case study for our project for this competition. For our UF Concrete Canoe team, using RCA as a lightweight aggregate source was brought about by a change in the rules banning the lightweight, hollow, cenospheric aggregates that we had used in previous concrete canoes. In search of a lightweight yet durable replacement, we chose to create our own recycled concrete aggregate from one of our team's previous concrete canoes. After several failures at obtaining RCA, we finally developed a standardized method through which we were able to use RCA as a lightweight aggregate to great success. Following the production and testing methods that Wes outlined in the previous slides, we started out by manually crushing the concrete at our lakeside storage facility in order to easily transport the concrete back to our lab and to be able to feed the material into our pulverizing machine. With this pulverizing machine, we were able to produce granular concrete sizes that could be sieved. The material that was retained on the number 8, the number 16, the number 30, the number 50, and the number 100 sieve were considered usable and was stored in airtight buckets in order to remain at a consistent moisture content. The material that passed the number 100 sieve was safely disposed of, and the material that was retained on the number 4 sieve and higher was then repulverized and then sieved again. Alongside creating a standardized process to obtain consistent RCA for use in our concrete canoe mix design, our team wrote a material and testing data sheet composed of the data that we had compiled from our standardized testing procedures in order for our aggregate to be compliant with the rules. All of our hard work paid off when we won both the Southeast Regional Championship as well as the National Concrete Canoe Championship in June of 2021.
Hello, my name is Joseph Atwater, and I will be discussing the broader impacts of using recycled concrete aggregate in new construction projects. By utilizing RCA, there will be a decrease in cost associated with aggregate, as waste concrete is typically more readily available than other forms of aggregate which need to be transported from a mining site to a concrete production facility. Waste concrete is also a primary source of waste in the construction industry, with the EPA estimating that around 85% of construction and demolition waste in 2018 being concrete and asphalt. This means that waste concrete can typically be purchased at low prices due to the high volume produced. Due to RCA having a lower strength than typical aggregates, it will be more useful in areas that don't require high strength specifications. RCA is perfectly suited to be used in lean concrete, curbs and gutters and roadways, and sidewalks. RCA does not increase concrete susceptibility to freeze-thaw cycles despite having a higher permeability. Because of this, it is possible to use RCA in situations where long-term durability is required and not limited to warmer climates. Because RCA does not need to be transported over long distances from typical mines, less CO2 is released during the transportation of RCA to a concrete production facility and finally to the construction site. The CO2 emitted for a typical cubic yard of concrete is around 400 pounds, and by reusing concrete instead of disposing of it, this will mean that this CO2 is not generated completely for waste, decreasing the overall carbon footprint of the construction industry.